Hi, good morning, everyone. Looks like we already have 9 people, which is great. Okay, let's just get started in a second. Good morning. Okay, it looks like we have about 12 people here. Yeah, we will get started. Okay, so last class we oh, I'm actually just gonna hop over to Discord. I forgot to set that up. Give me 1 second. Do that. And open Discord. There you are. Okay, open this up. Grade 9. I don't remember. I don't think too many people in grade 9 are using Discord. Doesn't look like anyone is online right now, but that's fine. I'll just have it open just in case. There we go. And okay, yeah. So I am on Discord now. So if you want to ask a question on Discord, feel free. Just put in some headphones just in case someone starts talking to me. I can hear you. Sorry, I totally forgot about Discord for a second there. Okay. Okay, we're ready to get started. Now we got 18 people, so that's awesome. Okay, last class we ended off just starting to talk about the distance between 2 points and how we would go about calculating that, and it really just boiled down to Pythagorean Theorem. It's probably one of the most used theorems in all of mathematics, so it's no coincidence that we're using it here. So I thought I'd start off just with an example. So if we just scroll back a little bit, let's take a quick peek at what the formula is. So the distance between 2 points, P and Q, that have coordinates x1, y1, and x2, y2, would be, well, really what we're doing is we're taking the difference of the 2 points, and then we're squaring them, because that's kind of like what this b would be here, right? And then we're going to take the difference between the y values, that would be a right here, and then we're squaring that. And then we take the square root of it, right? Because it's pretty much like the square root of a squared plus b squared, right? That's really what we're doing. So let's try this example here. Now, I guess I should mark what these values are here. So this would be 1, 2, 3, 4, -1, -2, and this is 1, 2. I mean, the scale is just what the grid paper on my screen is. Oh, that's -1. Okay, so this would be -2, -3, etc. So this point right here, this is going to be the point -5, +5, -5, +5. Come on. Okay, so that's that point there, because we go over 1, 2, 3, 4, 5 to the left, and we're having to go up 1, 2, 3, 4, 5 up. So that would be the point -5, 5. This point down here is the point, well, let's see. So I'm going down 1, 2, 3, and I'm not going left and right at all. I'm right on that y-axis. So this is the point -3, 0. So -3, 0. So I'm gonna do this one in just like, I'm gonna do it in two ways. The first way is I'm gonna draw a right angle triangle so that we can actually visualize what we're really doing. So I'm gonna just make a nice vertical line down here, and I'm gonna stop it there. And I'm actually gonna just move these guys out of the way. Let's put them over here, and I'm gonna make a horizontal line going from here to here, and I'm going to mark that as a right angle because those two lines are perpendicular to one another. So there you have it. There's our right angle triangle. And let's start to calculate the different legs, or the lengths of the legs of this triangle. So we could count it if we wanted to. Let's start by doing that. So we got 1, 2, 3, 4, 5, 6, 7, 8. So this side is 8. The other side, we've got 1, 2, 3, 4, 5. Okay, so we've got 5 on this side, which means that the distance between the points P and Q, why don't I call this point P and this point Q? That would help. So the distance between point P and Q is the square root of 8 squared plus 5 squared. And let's simplify that. So that's going to be the square root of 64 plus 25. And that is equal to the square root of, what is that, 89? The square root of 89. And I don't think that I can simplify the square root of 89. Is 89 prime? I should double check. I should know this off by heart. 89 prime. Yeah, 89 is prime. I thought it was. So because it's a prime number, you can't, like, there's no way that you could simplify that any further. So 89 is prime, so the square root of 89 is already simplified. But you'll notice here that I didn't actually use the distance formula to calculate this. I just drew a right angle triangle. So let's see how we would actually go about using the formula. So what I'm going to do is I'm going to assign the point P to be, well, this is going to be x1, y1. Okay, so in other words, x1 is -5 and y1 is +5. And then on the other end, I'm going to say that the point Q is going to have x2, y2. So in other words, x2 is -3 and y2 is 0. And then let's see how we would go about using the formula. So remember that using the formula, I'll just sort of do it over here, using the formula. Okay, when we use the formula, we get that the distance between P and Q, so I'll write dPQ is equal to the square root, and I'm going to be running out of room here. This is kind of silly to try to squeeze it in here, but I'll try my best. So the distance between P and Q is, well, I take the difference of the of the x's, so x1, or usually when we talk about differences, we'll do x2 minus x1, although it really doesn't matter because we're going to square it, so it doesn't matter which one comes first and which one comes second. The only difference between, like, when you change the order, oh, did I make a mistake? 0, -3. Ah, yes, thank you. 0, -3. Took a while for me to catch that one, but yeah, this is 0, -3. Thank you very much. Make any other mistakes? No, looks like we're all good. Okay, yeah, sorry about that. Yeah, 0, -3. Glad you guys are paying attention. Okay, so going back to here, if I change the order of a difference, like if I were to do x2 minus x1 versus x1 minus x2, like x1 minus x2, it doesn't matter. Like the only difference between these, like these two things are almost identical, x2 minus x1. The only difference is that one is the negative of the other. So it doesn't matter which one I put first and which one I put second, because I am putting an exponent of 2 on it. So I'm squaring it. So if one is the negative of the other, when I square it, it's just going to become positive anyway. So they become the same thing anyways. So we don't have to worry about which one comes first. So in the distance formula, you just take the difference of them. It doesn't matter which order you subtract them. It could be x1 minus x2 or x2 minus x1. Anyways, going back to the formula. Oops. Go back to blue. So this is going to be plus y2 minus y1 squared. Looks like I had just enough room. Okay, so let's use this formula, and I'm going to need more room. So I'm going to erase this, and I'm going to put this down here. So let's use this formula to calculate the distance. So I've got square root of, well, x2 we said was 0, x1 we said was negative 5, so I've got minus negative 5, so that's plus 5 squared. And I'm going to add, well, the y2 minus y1, so y2 is negative 3 minus y1, well, y1 is 5, so I've got negative 3 minus 5 squared. And you might notice that we actually have pretty much the same thing that we had over here. We had 8 squared plus 5 squared. Well, 8 squared plus 5 squared, well, we've already done that math, right? I've got 5 squared plus, well, and it's actually negative 8 squared. But like I said, if you have a minus sign inside those brackets, the exponent of 2 is just going to make it positive. So this is the same thing as positive 8 squared plus 5 squared. And we've already seen that this is the square root of 89. Okay? So that wasn't too bad. So I want to just quickly talk about what I'd like to, I mean, I'm not really seeing you guys. I don't get to actually see what you're doing while I'm delivering these lessons. Can we do it either way? I'll talk about that in a second. But what I'm hoping is happening is that when you're watching these videos, you do have some paper in front of you and a pencil, and you're actually, taking some notes and working on some of these problems. So in that vein, what I'd like you to do is I'd like you to actually try this problem. And I think I've got a timer here, so I'll put my clock up here. And I'm going to give you 2 minutes to try this problem, okay? I want you to calculate the distance between these 2 points, and the scale here is just one, like each box is just 1 unit. So, but just to be absolutely clear, I'll do this. -1, -2, -3, etc. You get the idea. But it is important to be clear about these things. This is 4. Okay, so I'm going to get you to work on this problem. Like I said, I'm hoping that you are actually following along here with paper and pencil, and not just sort of like sipping your coffee and watching me do all the work, because it is important to get practice, right? So I'm going to give you 2 minutes to do this one. And someone in the chat asked, can we do it either way? And for this particular question, it would be fine if you did it either way. The thing is, if I were to just give you the coordinates of the 2 points, and I asked what's the distance between these 2 points, you may struggle a little bit if you haven't had any practice using the formula. So I would actually prefer you to use the formula for this one. So use the formula. I'm going to hit go, and I'm going to stop talking so you can concentrate and try to solve this problem. By the way, I want your answer simplified. So simplify the radicals. If you can. It's possible that you can't simplify the radical. So I'll give you 2 minutes. I'll be right back. Okay, it looks like time's up. Okay. Okay, let's okay. Oh, it looks like someone already got the answer. Okay. So let's go ahead and solve this one. So I'm going to just use the formula. I don't want to draw a right angle triangle. The reason I don't want to draw a right angle triangle is because I want us to actually get some practice using the formula. And if we're just drawing triangles, then it's pretty much the same thing that we've been doing since, grade 8 when we're drawing right angle triangles and calculating the hypotenuse. So let's go ahead and use the formula. So this is the point, 2, 4, and this is the point -2, -2. So I'm going to say that this is the point P, and this is the point Q. So I've got P, -2, -2, and Q, 2, 4. So the distance between P and Q is equal to the square root of, well, I'm going to do -2 minus 2 squared plus -2 minus 4 squared. Okay. Okay. Anyway, so this is the square root of 4 squared plus 6 squared, which is square root of 16 plus 36, which is the square root of, 52? 52. Okay. Oh, someone said that it's 3. I don't think it's 3. I think it's something else. So square root of 52. 52, I believe, can be written as 4 times 13. 4 times 13. Right, so this is actually 2 times the square root of 13. Okay, so, 2 and the square root of, yep, Mad Dog MG got it right, it looks like. And that's what my computer said it was as well. So, perfect. Okay, let's try a more direct question. In the brackets, I had 2 plus 2 squared and 4 plus 2 squared. Is that correct? Yes. So my guess, so someone in the chat asked, so in the brackets they got 2 plus 2 and 4 plus 2 squared. Is that okay? Well, absolutely. So my guess is that you said that this point was P and this point was Q, in which case these would be swapped, in which case you'd be subtracting a negative, which would be the same as adding. So yeah, absolutely, that's fine. And that's kind of what I was saying. It doesn't matter which one you have first, because the only difference between like if you change the order of a subtraction question, what happens is that you get a multiple of -1. That is the same thing as multiplying the whole thing by -1. So if you square -1, then you get +1, and it ends up just all canceling out. So it doesn't matter which point you choose. That's what's nice about this formula, is that it doesn't matter which one you choose first. So it's all good. I'm going to do a couple more questions, and then I want to talk about sort of a new topic that we're going to jump into. So let's calculate the distance between these 2 points. We're going to have, let's do 1, 7 and -2, 4. Okay. So now we don't have a nice little graph, so we won't actually be able to draw a graph. We're just going to be using the formula. So let's go ahead and try that. In a lot of ways, it is kind of nice when you're not given the graph, because you just are given the points and you don't have to figure out what those points are. So I'm going to say that this one is P and this one is Q. So this is going to be x1, y1, this is going to be x2, that'll be y2. So the distance between P and Q is equal to the square root of, well, the difference in the x's, which is 1 minus -2, which is the same thing as 1 plus 2 squared, plus, and then bracket 7 minus 4 squared. Okay, and this is equal to the square root of, well, 1 plus 2 is 3, 3 squared is 9, and then we've got 7 minus 4 is 3, and then 3 squared is 9 again. So I've got 9 plus 9. This is going to be the square root of 18. Okay, and we can simplify this. This is something we can simplify. Of course, 9 is a factor of 18, and 9 is a perfect square. So this is equal to the square root of 9 times 2, which is equal to 3 times the square root of 2. Okay. Okay, there's going to be one more problem type that I want us to cover, and then we'll be good. So let's try one more problem, and then I'm going to sort of do the same thing where I get you to do a similar problem. So we're going to find the distance between, okay, so find the distance between, okay, I'm going to do 2 questions. One I'm going to do, and the second one you're going to do. So we've got, let's see, the point 2 times the square root of 3 and 0. So that's my first point. And the second point is square root of 3, comma, -5. Okay. So I'm going to say that this is the point P and this is the point Q. And now I just plug it into my formula. So let's go ahead and try that. So when I do that, I get that the distance between P and Q is equal to the square root of, well, this is where things get a little bit funky, but that's okay. We're just going to do our best. So I've got 2 times the square root of 3 minus the square root of 3 squared plus 0 minus -5, which is just like plus 5 squared. Okay, now let's get to work. So now I've got, let's think about what this is. So this is 2 times the square root of 3 minus the square root of 3. You can kind of think of that as like 2x minus x, right? And when you think of it like that, it's kind of obvious what this is. Like if I have 2 x's and then I subtract 1x, I've got just 1x left over, right? So if I have 2 times the square root of 3 and then I subtract the square root of 3. Well, how many square root of 3's do I have? Well, I've got one left. So 2 root 3 minus root 3 is the same thing as just the square root of 3 squared. Okay, plus, now I've got 0 plus 5, that's going to be just 5 squared. Okay, and I guess I should go back to green here. Okay, and now I've got the square root. Well, the square root of 3 squared is 3. By definition, that's what it means to be the square root of 3, is that when you square this number, you get 3 back. So I've got 3 plus the square root of 25, or sorry, the square of 5, which is 25. And this is the square root of, the square root of 28. Now, I believe I can factor this a little bit more. So, so 28, as you know, is 4 times 7. And I'm just going to go back up here. And 4 times 7, when I take the square root, I would have 2 times the square root of 7. So this one is 2 root 7. So, why did the 2 disappear? Which 2? Oh, over here? Where did this 2 disappear? Is that what you're asking? So I had 2 root 3 minus root 3. So 2 root 3 means, like, I've got 2 of these. It's like 2 times the square root of 3. 2 times the square root of 3 minus root 3. So this is kind of like root 3 plus root 3, right? That's what 2 times anything means. It means add it to itself 2 times. And then I've got minus root 3. So if I have root 3 plus root 3 minus root 3, well, these root 3's cancel, and I'm just left with a root 3 left over. So I was kind of likening it to algebra. Like if we said that root 3 was the same thing as x, we would have like 2x minus x, which is just x, right? So 2 root 3 minus root 3 is the same thing as just root 3. So, yeah, I want you to try this one for yourself and see how far you can get. I'll leave my work open so you can kind of use that as a reference if you need. This time I'm going to give you 3 minutes to do it. So I'm just gonna reset this. Okay, now I'm gonna do this one here. Hold your horses. Okay, yeah, let's do this one here. Let's do question B, right? Because this one was question A. Question B is to find the distance between these 2 points. I've got 2 root 2 and 4 and root 2 and negative 3. Okay, I don't get the part where you turn the 4 times 7 into 2 times 7. Okay, let's pause. Before we start that, where does this part come from? Okay, good question. Okay, so where does the 4 root 7 turn into the 2 root, or so the square root of 4 times 7 turn into the 2 times root 7? So let's do this. Let's say we've got, so the square root of 4 times 7, that's equal to the square root of 4 times the square root of 7, which is equal to 2 times the square root of 7, right? Because the square root of 4 is just 2. So that's where that came from. Okay, so yeah, there's where that comes from. I'm gonna give you 3 minutes to try this problem, and then we'll take it from there. Okay, so I'll give you 3 minutes. I'll set the timer, and you can get started. Go ahead. All right, that's time. Let's see what we got here. I don't think it is 3. It looks like some people are thinking it's 3 times the square root of 17, maybe square root of 51. Let's see what we get. Okay, so I'm gonna say that this is the point P and this is the point Q, and we'll see where we go from there. So that would make this x1, this would make this y1, this is x2, this is y2. Okay. Now we've got, I've got the square root of x2 minus x1. Actually, let's do x1 minus x2. That'll make things a little bit easier. So I've got 2 root 2 minus root 2 squared plus 4 minus negative 3, so that's 4 plus 3 squared. Let's see what we get. Well, 2 root 2 minus root 2 is just root 2 squared plus, 4 plus 3 is 7 squared. Okay, so I've got root 2 squared plus 7 squared, so that is equal to, well, I've got the square root of, root 2 squared is just 2. 7 squared is 49, so I've got 49. Look at that. And I've got that this is the square root of 51. Now, okay, so the square root of 51, I don't think I can simplify that. 51 is, so if I were to find the factor tree for 51, 3 goes into 51, and 3 goes into 51, I believe, 17 times. So, yeah, both of those are prime numbers, so we can't actually simplify that. So it is just the square root of 51. So looks like that's all we can do. Okay. Okay, next up we have okay, hold on a second. Okay, so that's pretty much all I want to do for the distance formula. The next thing I want us to do is hold on a second. Oh, why wouldn't we write this as 3 times 17 squared? Okay. The idea here is, okay, so this already is simplified. It's pretty much just, it is what it is. We can't simplify this anymore. So if you wanted to, you could do the square root of 3 times 17, but that isn't any more helpful than just the square root of 51. So yeah, the only time that we'd be able to simplify it is if one of these factors was a perfect square, in which case we would take that square root and have it as part of the factor of one of our entire radical here. So yeah, we're not going to be able to simplify this anymore. So it is just the square root of 51. So that's the final answer. Okay. Okay, so in the homework for today, we're going to do a few more of those questions. So yeah, I'm going to give you some more of these questions to work on today. Looks like we've got about 8 minutes left. So I'm gonna leave. I think I'm just gonna leave it there because the next topic that we have is kind of a big topic. So I don't want to, I don't want to jump into a brand new topic when there's only a few minutes left of class. So we'll end a little bit early today. I'll put the homework on the website, and there's going to be a good portion of the homework that you're not going to be able to do because we haven't done it yet. So the second half of the homework, there's going to be, I'll just say, it says solve each system. You're not going to be able to do that question. So, you know what? Maybe I'll just actually take it off the homework. Yeah, I'll take it off the homework for now. And who's Jaxie Bob? That's a former student of mine. So yeah, I'll take off that stuff. Come on. Yeah, you know, I'm not gonna do that right now. I'm just gonna post your homework now, and it'll just be a short little bit of homework. It's something, yeah, it's just gonna be a reflection of what we did today. So yeah, work on that for today. Okay, and oh yeah, so few questions in the chat. So are we supposed to be submitting our homework to Google Classroom? No. Your homework is just your homework. And I think I answered that last class. So yeah, no, you're not supposed to be submitting your homework to Google Classroom. The only thing that I want you to submit on Google Classroom is like any kind of like assignment that's worth marks. Your homework is not worth any marks. It's just for your own practice. It's a good idea to practice this stuff, because when you do have an assignment, you don't want your first attempt to be the one that's worth marks. It's much better to make mistakes and to, you know, sort of challenge yourself when the stakes are low. So keep that in mind. Yeah, so I'm gonna leave you there. I am gonna post your marks on Google Classroom shortly. So hopefully I'll get to that today. But if not, then I'll do that tomorrow. When are we getting the marks for the assignment? Hopefully today or tomorrow. Same thing. So yeah. So yeah, I'm gonna sign out now. If you have any questions, don't hesitate to ask. Maybe on the Discord or on Instagram, whatever you like. But yeah, I'm gonna sign out now, and I will talk to you guys on Tuesday of next week, because Friday is not Friday's Good Friday, so we have so we do have homework then. Yes, I will be posting homework on the website today, but it is not worth any marks. Anyway, yeah, I'm gonna sign out now, and yeah, don't hesitate to reach out if you have any questions. Yeah, take care.